Okay, let's do 6.2, question number 8. Let's read the question first. Using theorem 6.2, okay. Theorem 6.2 is the converse of Taylor's theorem. Converse of Taylor's theorem. Okay. So before we go any further, let's just review what it was Taylor's theorem and what was converse of Taylor's theorem. Taylor's theorem was when in a triangle, if this and this is parallel, then this side, let's say ABCD, ABC XY. So AX by XB will always be equal to AY by YC. This is Taylor's theorem, right? And then what was converse of Taylor's theorem? Converse of Taylor's theorem is opposite of this. So in a triangle ABC XY, if, see here, if in Taylor's theorem, okay, if XY is parallel to BC, if XY is parallel to BC, then AX by XB equal to AY by YC. But in converse of Taylor's theorem, it's if AX by XB equal to AY by YC, then XY is parallel to BC. So itu has the Taylor's theorem de parallel digina aje, parallel digina takha karne itu aje. Na converse of Taylor's theorem de ratio same as equation, ratio same as equal karne parallel as. Okay, don't get confused. Okay, so theorem 6.2 converse of Taylor's theorem is this one. So if the ratios are same, then it is parallel. So we have to show that the ratios are same. So in order to prove that it's parallel, got it? So using converse of Taylor, prove that the line joining the midpoints of any two sides. So what is midpoint? Midpoint means the middle point. Okay, middle point in the sense if I draw a line and this 10 centimeter, this the middle point, then this will be 5 centimeter, this will be 5 centimeter. It divides, it's the middle of the line. Okay, so prove that the line joining the midpoints of any two sides. So this is the midpoint of AB and this is the midpoint of AC, and then we're joining the two midpoints. We don't know if this is parallel or not. We have to prove that this is parallel. Okay, so what is given in the question? Given D is the midpoint of what? AB, and E is the midpoint of AC, right? D is the midpoint of AB and E is the midpoint of AC. To prove, we have to prove that DE is parallel to BC. So proof, okay. See, converse of Taylor's theorem says if the ratios are same, then it is parallel. So all we have to show is that the ratios are same. So let's try to show that the ratios are same. So ratios means this divided by this. Okay, this AD divided by BD. Okay, AD. Before we do division, we're gonna do this. Okay, AD equal to BD, and then AE equal to EC. Why? Because D and E are midpoints. If D is the midpoint, these two, by chance it full to 8 centimeters with the 4 no? So these two is same, right? If this is 10 centimeter, then it will become 5. So these two is same, right? So just like that, AD is equal to DB because D is the midpoint, and AE is equal to EC because E is the midpoint, right? So now AD divided by DB equal to, now when I divide AD by, why I'm dividing AD by DB is that because I need to show that the ratios are the same. Ratios matlab what? This by this should be equal to this by this. That's what I'm trying to show, right? This by this is equal to this by this. So I'm dividing this by this in order to show that. Okay, so AD by DB equal to, now AD is equal to BD, right? AD and BD is same. So I can write, let's make this equation 1. AD by, instead of BD, can I write AD? Right? Itu 4 cm lagi. Itu 4 cm, which means 4 for you, na? Itu di sini. Equal to 1, right? Let's make this equation 2 and then write reasons. Okay, now from equation 1, the replacing part, na? So AE by EC equal to AE by AE. Exactly the same wording. Instead of EC, I'm putting AE. So this is from equation 1 again. So this is equal to what? Equal to 3. Itu ditala ratio 1 by C. Itu ditala ratio 1 by C. Which means the ratio is the same, right? Therefore, AD by DB equal to AE by EC. Hence, by converse of Thales theorem, what is parallel to what? DE is parallel to BC. Got it? Since we showed that the ratios are same, hence the sides will be this and this should be parallel. That's number 9. ABCD is a trapezium in which AB is parallel to CD. So trapezium, what do you understand by trapezium? Trapezium means any figure, okay, any quadrilateral which has only one side parallel to each other. Not two sides, just one side. And there's no special properties of trapezium. It's just that one side is parallel to each other. That's it, nothing else, okay? So they're asking us, this question is quite important only, okay? ABCD is a trapezium in which AB is parallel to DC. So they're saying AB is parallel to DC, huh? And its diagonals intersect each other at point O. O, they intersect each other. By the way, for example, in this question, they did not give you the diagram, right? You have to draw your own diagram. So whenever you're drawing your own diagram, suppose you drew a trapezium right now. Now, when you're naming it, okay, ABCD, when you're naming ABCD, because I've seen some students do the same, do these mistakes. You're supposed to go serial wise, clockwise, or anti-clockwise, okay? A, B, C, D, like that. A, B, C, D, like that in one go. You cannot go A, B, C, D. A, B, C, D. You have to go serial wise. A, B, next will be C, D. Not A, B, C, D. Okay, remember that. So, after making the diagram, diagonals intersecting at O, we have to show that AO by BO equal to CO by DO. So we are using the diagonals. In whatever they're asking us to prove has to do with the diagonals, because AO is part of a diagonal, BO is part of a diagonal, CO is also part of a diagonal, and DO is also part of diagonal. So it has to do something with the diagonal. Now, we know that we have to use Thales theorem or converse of Thales theorem. In this case, we have to use Thales theorem because we already have parallel lines, right? Converse to ratio same parallel as it. If the ratios are same, it's parallel, na? That's converse. But if it's parallel, then the ratios are same. So that's Thales theorem. So already parallel lines are here. So which means we have to use Thales theorem somehow. And in order to use Thales theorem in a triangle, okay, in any triangle, there has to be a line parallel to the one of the sides of the triangle. So can you find any triangle like that? Like that? Can you find any triangle in this case such that one line is parallel to the other? Pitor line. In this triangle. So that's why we have to construct. Okay. So construction. Since there's no line parallel, I am going to construct a line parallel to then. Let's say M or P. Construction, draw. See, I drew it here, not PO. You can draw. You could have drawn here also OM something. Doesn't matter, but it has to be parallel to either this or this, right? Because if you draw if you take the triangle this way, then these two will be parallel. So we can apply Taylor's theorem. If you take the triangle this way, then this line, green line and blue line will be parallel. So we can apply Taylor's theorem again there, right? So it has to be intersecting the intersection point of the diagonals and parallel to either one of these. So you can draw it this side, you can draw it this side, doesn't matter. I'm just doing triangle like the triangle like the Taylor's theorem apply to Taylor's theorem apply to one in the it is a parallel. So I took any triangle and then I just draw a line parallel to this so that we can apply Taylor's theorem. Okay. Draw PO parallel to, let's say, AB. I guess, I don't know, doesn't matter. You can say draw PO parallel to DC also, doesn't matter. So but AB is parallel to DC, which is given. Therefore, see, I drew PO parallel to AB, but since AB is already parallel to CD, automatically this tree will become parallel. It is a line neutral. Okay? Parallel means if you extend this, it will never ever join. It will never diverge, it will never converge, it'll just go straight like that, right? So if I draw a line parallel to one of the lines, then this green line and the blue line, PO and AB, it will not touch, it will just go on. So just like that, these two also will become automatic parallel, right? So therefore AB is parallel to PO is parallel to CD or DC, doesn't matter. Got it? Now let's take the triangles. In, see, green line that, and this line is parallel to this CD. So we'll take a triangle which includes PO and CD, which is ADC. In triangle ADC, okay, we can say AP by PD equal to AO by OC. By Taylor's theorem. We just showed that this two is parallel, so by Taylor's theorem we can say AP by PD equal to AO by OC, right? Let's keep this equation 1. Again, in triangle, now let's take, see, these two parallel, so I took a DC triangle. Now, but this two is also parallel, right? PO is also parallel to AB. So let's take the triangle which includes PO and AB. That is what? ABD, right? So in triangle ABD. So let me just turn this a little bit like this so you guys can have a better idea. So in this triangle, see, we're taking ABD, okay? In this triangle, these two is parallel, right? So if this two is parallel, we can say what? This by this or this by this equal to this by this or this by this. Doesn't matter. But itu portion ekta. Nah? AP will be one portion, PD will be one portion, BO will be one portion, OD will be one portion, right? So in triangle ABD, I'm gonna take in according to what we already got. Okay, we took AP by PD, right? AP by PD. So in this case also I'll take AP by PD equal to, now I'm taking AP first. So in this triangle, we're talking about this triangle, I'm taking AP first, so I have to take what? BO next, nah? So BO by AP by PD, so BO by OD. Same tells you. Equation 2. So from 1 and 2, we can say that, see, AP by PD, AP by PD, so this two is equal to AO by OC equal to BO by OD, nah? But it's not over, okay? If you look at what they were asking us to prove, they're asking us to prove what? AO by BO equal to CO by DO, right? And then we did not get AO by BO, right? we got AO by OC equal to BO by. So what we're gonna do is we're gonna try and arrange this in such a way that we get this. So I'll cross multiply first, okay? So when I'm cross multiplying, you don't have to do the red part, but this will come up and multiply, this will go up and multiply, right? Don't write these arrow marks, okay? AO into OD equal to BO into OC. Now I will arrange according to this, okay? AO is here, AO is here. I need BO on the bottom. So BO, I'm gonna send this side. So since this is multiplication, if I send BO this side, it will become division. So AO by BO equal to OC is on top, so it will remain on top. If I send OD this side, it will become division since it's multiplication. So OD. Now we got AO by BO, AO by BO, CO by DO, or OC by OD, same thing. Hence proof. Got it? Please understand this question very properly, like nicely, so that because the next question is very much related to this, okay? It's just the reverse of this. So question number 10, let's do. I'm gonna keep this S here only so that you guys can understand it properly. So the diagonal of a quadrilateral ABCD. So this is a quadrilateral, not a trapezium. Don't get confused. It's not a trapezium, it's a quadrilateral. Quadrilateral means any four-sided figure. This is any four-sided figure ABC. Okay, a quadrilateral. Intersect each other at point O. The diagonals intersect at point O, such that they've given us they intersect at O such that AO and B by BO equal to CO by this. This is already there. We have to show that ABCD is a trapezium. Ito na. Question number 9 and 10 is like kind of like this. If this is parallel to this, show that these ratios are same na. If the ratios are same, show that these two are parallel. Ulta ho jayega na, flip ho jayega na. Just like similar to this only. Here they ask us to show that this by this equal to this by this. Now they're saying if this by this and this by this are equal and it is not parallel, show that it is parallel. Here, okay. So here in this question, it's opposite of this. So what we're going to do is we're going to do opposite of what we did here from back side. Okay, on the back will go up. So but before that, construction we'll have to do. So construction, same construction only, don't worry. Construction, draw PO parallel to AB. Let's say. So we're drawing PO parallel to AB. PO parallel to AB. But the difference between the previous question and this question is that in the previous question, what happened was AB and CD were already parallel, right? AB and CD were already parallel. We drew one line parallel to either of the sides, and automatically this line became parallel to both the parallel lines, right? But in this case, they never said that this and this is parallel. So even if I draw this line parallel to this line will not be parallel to this, okay? And this line is also not parallel to this. Only these two lines are parallel. From what we know, this figure might even be something like this also. Who knows? Just because I drew like this, don't get confused, okay? It might be like this also. This is also a four-sided figure. And if I draw a line parallel to this, let's just draw a diagonal. This is a diagonal. If I draw a line parallel to this, parallel, these two parallel, doesn't mean that this and this will be parallel. See, this is going like this going like this, right? So just because I drew this parallel, it doesn't mean that this will become parallel to this, okay? Or doesn't mean that this and this is parallel also. So keeping that concept in mind, these two is parallel doesn't mean that it is parallel to this. So what do we have to prove? We have to prove that ABCD is a trapezium. But what did I say trapezium is? Trapezium is a figure where one side is parallel, right? One opposite sides are parallel. So to prove ABCD is a trapezium, or AB is parallel to CD. If we can show that AB is parallel to CD, then ABCD will automatically, you can say that it's a parallelogram, I mean trapezium, right? So proof. So as I've already told you, we're gonna go here from the this thing. So they have given us what? Given AO by BO equal to CO by DO. Nah? This is what they've given us. AO by BO equal to CO by DO. So before this, what did we do? We did this, right? Itu takina itu aja. So cross multiply version. So we'll cross multiply again. AO into DO equal to AO goes up, DO goes up, BO goes up. So CO into BO. Now here it was what? AO by OC, BO by OD. So here also I'm gonna do AO divided by OC, because OC is multiplication. If it goes this side, it becomes division. BO stays up. If DO goes this side, it will become division, right? So in exam, if this question comes, this is, I'm showing you backwards, but exam review itu question back if it like, so how would you know what to do is just it has to be like this. This side diagonal has to be on one side. This diagonal has to be on one side. Okay, so AO by OC, the same diagonal, AO by OC, AO by OC equal to BO by OD, BO by OD. What they have given in the question is AO by BO. It's like half of part of the diagonal on one side, right? So you have to make it the whole diagonal in one side, the whole diagonal in one side. Okay, once you have done that, what we're going to do is up to here we'll mark it as equation 1. Okay, now here where can we apply Taylor's theorem? We drew PO parallel to AB, right? So we can apply Taylor's theorem in the triangle which includes the two parallel lines ABB as a POB as a. Which triangle is that? ABD, right? In triangle ABD. So let's do this. In triangle ABD, we can say that this by this equal to this by this, or we can even say this by this equal to this by this, doesn't matter. But Taylor's theorem, this one portion, this one portion, this one portion, this one portion, we can use Taylor's theorem here, right? So by Taylor's theorem, we can say that see, if I do this portion by this portion, then it will be equal to this portion by this portion, right? The triangle, this by this equal to this by this, right? So I'm going to be doing this by this by this, because I want BO by OD. Here we have BO by OD, so I want this by this. So I'm going to do AP first. AP by PD equal to BO by OD or DO. Equation 2. From equation 1 and 2, BO, BO, OD, OD. DO, OD, same thing, okay? Like the line as OD, DO. If this 2 centimeter, OD is 2 centimeter, DO is 2 centimeter, doesn't matter, okay? So this and this is same, which means these two should be same, right? So AO by OC equal to BO by DO. This much you understood. So get a blank page. So this much is done. Now I'm gonna take, now see, if you look at what we got here, okay, AO by OC, AO by OC, right, equal to BO by, what the hell am I writing? Wait, look at this. BO by OD, BO by OD. So these two is equal now. So AO by OC equal to AP by PD. Sorry about that. E2 equal to BO by DO. E2 equal to BO by DO. So E2 or E2 same way. AO by OC equal to AP by PD. Huh? Now, if you look at here, AO by OC, and look at the diagram, AO is this, OC is this, and here's AP by PD. AP is this, PD is this. So this, right, which triangle are we using? This by this, this by this, which means we're using triangle ADC. So I'm gonna put now in triangle ADC AO by OC, I'm going to write exactly the same, okay? AP by PD, PD, na? Therefore, by converse of tail theorem, PO is parallel to DC. If you did not get that, why I did that, let me draw the diagram here. A, D, C. A, D, C. We're taking ADC, right? ADC. And then we have here P, O. And then here we just showed that AO by OC, this upper portion by this portion equal to AP, this portion by PD, this portion, right? So which means what? Converse of tail theorem says that if the ratios are the same, these two is parallel, right? That's why PO is parallel to DC, nah? So, but from construction, what did we do construction? But from construction, PO is parallel to AB, right? Construction, the PO is parallel to AB. So, therefore, AB is parallel to DC. Why? Because we just showed that PO is parallel to DC, and then but in construction, PO is parallel to AB. So since PO is parallel to this, PO is parallel to these two should be also parallel to each other. So AB is parallel to DC. Hence proof. Hence ABCD is a trapezium because one side is parallel. So we just proved that PO is parallel to DC and AB is parallel to this. AB and CD are parallel. So hence ABCD is a trapezium. Got it?